mentally, math!
Let's get mental!
Alright. Okay. Going to give you a couple of minutes to get out ahead of me.
That's not the lesson. We're on lesson 100 and what?
104.
Cool. That's it.
But it's almost better if you're not looking at the book, because I'm going to be asking people to figure out these examples themselves, because you totally can.
It's very.
So it's really part of the class discussion. So if you're not looking at the answers in the book, I know you're puzzling it out for yourself. You're not just calling out what's in the book.
But I don't. Wait. I just read the problem.
Okay, well, that's fine. Nothing wrong with that. I believe you.
For B, do we have to put it inside?
You do not have your math scores yet. I have not graded them. I will do them tomorrow while the CTP is going on.
No.
I just got the other classes math test
B,
done.
do I have to put it in scientific notation?
Yes. So just to reiterate about. Oh, and they do say scientific notation, but the answer key for the book has been doing it in scientific notation this whole time, so we decided to just do it in scientific notation, whether or not it says scientific notation. And they should not take you very long. They're pretty simple, so I'm gonna give one deep yoga breath here. And get started. Okay, so we are looking at a negative sign and a negative value, which means we are actually going right on the number line for that. So we are actually subtracting the 25 hundredths from the 75 hundredths, getting us 5 tenths, or 50 hundredths. And then, okay, that's great. Then we can look at this a couple of ways. You can look at 5 plus 5, or 5 times 2. Multiplication just being repeated addition. So 5 times 5 is 25, but as mentioned, scientific notation. So times 10 to the power of, and since I divided this by 10, I'm going to multiply it by 10 one more time over on this side for an exponent of 11 to the power of 11. Then here we are adding 20 to each side, so 100 divided by 4 is 25. And then remember, if there are 3 feet to a yard, it's actually 3 times 3, getting you 9 squiffs, square feet. We're getting squifty. Get squifty. All right, and so 200%, just times 2. $50, and then to say 200% more than 25 is to say 50 plus 25 is $75. And then this seems surprisingly simple, really, as well. If the yard is shaped like an octagon, each side measures 4 feet, then the perimeter is going to be, shockingly, 4 times 8. Is 32 feet. I know, it sounds crazy. Then for this, so 45 minutes is 3/4 of an hour. And so we're looking at 3/4 of 12. Being 9 miles. Now that one's pretty. These mental math seem pretty relaxing and satisfying. And really, this whole lesson is pretty relaxing and satisfying at the same time. Semicircles, arcs, and sectors. It really is just taking things you already know and just putting those, using a little bit of deduction and putting together pieces of, to do things that we haven't done yet. Oh, also just a note, I believe that this is as far as I've ever gotten in the book, because year before last, things got sort of blown apart for a little while because of COVID, and so we didn't quite finish the book. And then last year with Online Academy, we started with Buzz, and then the second half of the year was sort of a patchwork of Saxon. So we are into kind of uncharted territory for me, so this is fun. I think there's an excellent chance we can finish the book by the end of the year. Yo!
For the problem, what should we use pi as? 3.14 or 22.7?
3.14.
Okay.
Yeah. Okay, so find the perimeter of this figure. Dimensions are in meters. So let's take a look at this. So we know what the diameter is. Or sorry, we know what the radius is, and we know the value of that little section. And so just for starters, let's just think of how would you figure out what the perimeter of half a circle, otherwise known as a semicircle. So we're looking at half of the circumference. So I mean, don't worry, this is just as obvious as it looks. So how would we find that? Yeah.
You could find the circumference and then divide it by 2.
Ta-da! Yeah. And so our formula for that would essentially be pi times the diameter divided by 2, like what you said. And so we can start just by looking at that. So let's see how far you can get along without me. I'm going to take a deep breath, let you move along here. So that would be times 10, right? So just 3.14 times. Oh, and you know what? It's not equal to that. It's sort of wiggly equal. Because you've got some wiggle room in there.
Nice.
Yeah, right. Okay, then times, and then so if we know wow, that's really loud. If we know the radius, then we know the diameter. Right. And then that's all divided by 2. So otherwise known as 31. Sorry, I'm doing this terribly. My father should just make you into a bird. Channeling Bob Ross. Okay, divided by 2, and so, huh? Oh, he's a famous art teacher, and if you make a mistake, he says, "Oh, there are no such things as mistakes. It's a happy accident. Just turn it into a bird." Yeah. Okay, and that's really all the time I should spend babbling about that. Okay, and then someone want to tell me what would half of 31 and 4/10 be? Yes, sir. One more time.
15 and 5200.
Mhm.
No, 15 and 7.
Yeah, so we can just think the 30, 15, and we can think of that as 14 divided by 2. Okay, so then that gets us to where we've got the value of our semicircle. Here, so I'm just going to clear that out of the way and just get that up there. And just in case you're wondering, no, there is no reason why you couldn't use 22/7 for that.
So what's the formula?
The formula? Oh, well, we have that up there. It would be, for a semicircle, pi times the diameter divided by 2.
Oh,
You know, which, yeah, it's not hard to figure out. And then, which clever person would like to tell me how we get the value of this side? Yes, sir.
So basically, the radius of the circle is 5, and that means, and since that dotted line is basically the diameter.
Yep.
And 5 times 2 is 10, and since those two lines are the same, they're both 10.
Excellent, sir. Yes. Oh, by the way, I'm not gonna walk over there, but I am kind of tallying up a couple focus points. Class has 2 focus points right now. Got a focus point for that, and for what they're doing over there. Okay, so we have that, and so that leads us to where we have enough information to solve this. I'm gonna take a couple of deep breaths and let you do that ahead of me. Yeah, so basically you're doing 15 7/10 plus the 10 plus a couple of 4s, right? And I'll just save us a step and say 8. I'm adding those to do a little mentally math, adding those together in my head. If that's all right. We're getting us to 33 and 7/10 meters, approximately. Right. Oh, no, you're the ones that did it. You don't need to clap for me.
But still.
But it's pretty satisfying, right?
Yeah.
Okay, so bringing us back to this guy again. Now let's figure out how to get the area.
Basically.
All right, so to start out with, now it's the same sort of thing as we did before. Is what is the formula for getting the area of a circle? Oh wait, I want to call the same. Yes.
The radius squared times pi.
Yeah. So pi times radius square, and then what are we going to do with the area of that? We're going to. I still want to keep calling the same people. Yeah. So here's a hint.
By 2.
Yes, exactly. That sort of thing. So doing that and applying that. Give you a moment. Okay, or we can say 3/1400ths times 25 square meters, and then we take the value of that, divide it by 2. Right. So then you go like that. Give you a moment to do your calculations. Okay. Then 1, 2. Bink. So then you take that, plug it into there, divided by 2. And I'll spare you the long division. Okay, well, just to say, 30. Point, that'll end up being 2.5. Okay, so we get this. The circumference, or the area of the semicircle will be about 39 and 25 hundredths of a meter squared. Okay, so we got that, and then we add that to the other part's pretty simple, right? We already knew that this was a value of 10, so just 4 times.
10.
Okay, thank you. Yeah, everyone could have done that. Okay. So then that gets us to, it's about 79. Oops. Yeah, I know. I see it. Typo. Is that what you're gonna? Yeah, okay, sorry. Sorry. Turn into a bird. There. That's better.
Actually, it kind of looks like it kind of has its eyes and eyebrows.
I know.
Yeah.
Okay.
How?
Fine. Okay, anyway. No, I don't know. Okay, anyway. Square meters. Okay. So,
This one's really fun.
yeah, this next one's interesting and also very, very satisfying. There's a couple different ways you can look at it. They made this one really, really simple just to sort of demonstrate something you could do, but there is definitely also a shortcut to it. So find the area of the shaded vector. Now, to start with, now, the first thing we could do, our first step in figuring that out would be to do what? Ooh, anyone haven't called on? Yeah! Oh, no, we're not, we're actually not too worried about degrees yet. Yeah?
Find the diameter?
Oh, no, I think the diameter is kind of a gimme, and we don't actually need to find that. We're trying to find the area. So it's not the diameter we're worried about. I really want someone I've been called on. But I don't really have, yeah?
Wait, was the question what do you need to find?
I'm asking what's the first thing we should do? What's our step 1? Okay, well I think it's his turn. Yes.
The area of the entire.
Find the area of the entire circle, which we get, of course, remember, so we get it by saying pi times the radius squared. Okay, so that'll be our first step. Now, if this is 300 degrees, then what does this have to be? Yeah. 60 degrees. I'll make you yellow since we're on a... Okay, and what fraction of... And so that makes, the entire thing, of course, 360 degrees. What fraction of 360 degrees is 60 degrees? Okay, what, Blurty, what did you say? 1/6. So we can, that can be our formula for this.
It looks like a smiling face, to be honest.
Okay, that's nice. Then, so doing it out, now we can say, now, so I could say that, right? However, the book wants to show us an interesting trick. So the book goes, well, oh, and by the way, oops, sorry, I actually should have said, I should have said that, right?
What example was this?
We're on example 3. Sorry, I know it's sort of cut off from the top of the word. So, yes, we could say 36 square centimeters, and you wouldn't be wrong, and you could kind of do the same thing, but the book has an interesting thing to show us here, is if we do it this way, what can we do to... You look really excited.
You can cross cancel.
Cross canceling goodness, people! Ta-da! So now so that's 1, and that ends up being 1, which is really nothing. And so you can now it's a way you can simplify things so that you're just it kind of takes out a step. Kind of starts you out with a more simple, or unless you finish with a more simple kind of work. And just to be a little bit spoilery, gets you to 18 and 84 hundredths square centimeters. So how are we feeling here? 1, 2, or 3? Okay. Are there, if you're not a 3, are there any questions, or are you just thinking, boy, I got some new formulas to memorize?
Practice.
Yeah, you just need to practice it some, but the concept itself seems pretty clear. 5?
No.
Oh, do you have a question?
Yeah, my brain, and it's just a comment. My brain is bulging right now.
Oh, okay, but it's really just taking pieces of what we already know. And I bet if I left you with it for 15 minutes, said, okay, you got 15 minutes to figure this out, I bet you could. Just saying.
Are you gonna do that?
Well, we're gonna do the lesson practice, but I'm just saying that, like, I think all of these are ones that the class, like, if you broke up into small groups and were given these questions, I bet you could puzzle it together just using pieces that you already know. Yeah.
So you have to find the area of the circle before you can do anything else?
Yeah, pretty much. Or at least, now this isn't finding the area of the circle, but it's setting up a formula for the area of the circle that you can work with from there. Like, you could have just as easily... you could have just you could have done it in a different order. You could have gotten the area of the circle first and then just divided that by 6. That would not have been a problem. They kind of made this simpler by having it all be kind of units of 6. But you could have just as easily gone, oh well, you could have just as easily done that, right? Because 36 divided by 6 is 6. So there are multiple paths, or you could have just gotten the area of the circle first and then divided that by 6 using long division. That would have been also fine. There are different paths to getting there. So I guess the way we're doing it here, it kind of helps us see what the numbers are, and also gives us kind of a little tool we could do to sort of simplify our final steps by the cross-canceling goodness. Okay, well, if your brain is bulging, that's okay, because this next one will help you let out a little bit of that steam, because you're going to find this maybe almost a little insulting. So, in this figure, our central angle is 70 degrees. Okay, I see, you're laughing now. Also, yeah, you see, I told you. And so it's asking, well, how can you, yes, we could all say it together. So, if that's it, and the whole thing is 360 degrees, then what does the other one have to be? It has to be 3. There's no 3 in this! 2. 290 degrees. Oh, no, it's all right. It's all right. It's just funny. It's just funny. No. There's no thing.
Go down 290.
Okay, 290 degrees, and we're done. Okay, yeah.
Bye, boy.
Yeah. I guess. Let's see. Maybe there's a little. I guess there's a little bit of vocabulary here we could talk about. Is No, well, we already know that one.
Major arc.
Yeah, please let me just. I could just say. I mean, I know you're reading the book, so I can do that just as easily. So yeah, the smaller one is called a minor arc, or essentially though. Here's the thing, and this is actually sort of important for. Like you're gonna kind of need this for the classwork. Now, when they talk about the arc and the angle of the arc, now the arc is technically the outside, right? That's the arc, and so the smaller one is called the minor arc, and the larger one is called the major arc, and Now, and I know that like they'll say what's the angle of it. So when we think of angles, we feel like we're measuring like the part on the inside, right? Like that's where we're at. But when we talk about the angle of the arcs, we are talking about the outside edge when we're talking about the arc. But so this arc has a measure of 70 degrees, and this arc has a measure of 209 degrees. So, we're talking about the outside, but that is the way that we think of it, as the minor arc and the major arc, and they do have a value of degrees. Even though usually when we measure for degrees, we kind of show that like showing as far on the inside as you can. Does that make sense? Okay. Just a little bit of vocabulary. Okay, this one's also a little insulting. So.
Oh wait, I get it.
So, the question here is to find the distance of this arc. So, how would we do that? Right. What's our formula here?
No way.
Yes, sir.
Divide the whole circle first, and then divide by 4. So basically,
Yes.
wait, can you just be pi times?
Well, the diameter. This is technically the diameter, right?
Wait, is it area or
No. Sorry. It is the length.
perimeter?
The length, perimeter.
Oh.
It's kind of, well, it technically isn't called perimeter. I don't think it's just the length of the arc.
Okay. The array.
Yeah, and then so the pi times the diameter divided by 4, right? And then doing that, and then this is another thing. So that if we write the formula, so 3 4/10 times, and we're just working with units, so by 4 units. So this is even more insulting.
Seriously?
What is it?
Oh my
God.
Seriously?
Ta-da! And that's the lesson, people.
I know I'm in a confidence because